sometimes when we're multiplying and dividing, we might see complex fractions, or where there's more than what's going on than just a basic numerator and a basic denominator. There might be more operations involved. So we have a few examples of what you might see in the book, and not to get too freaked out when you see them, because you already know how to do everything. You've already been taught in previous chapters. It's kind of just combining these and putting them all together now. So our first one, we have 2/3 divided by a -8/9. Oh my goodness. So it's like we have a fraction inception here. Fractions and fractions. Well, just remember this fraction bar is basically a division sign. So even though this is considered a complex fraction, you've already been doing this problem in the other section. Okay, so this right here, this problem can be rewritten as 2/3 divided by a -8/9. And since we don't like to have two signs right next to each other, we would go ahead and put that in parentheses. So really, when you write it like this, it doesn't look as scary. So just keep that in mind when you have a fraction on top and then a fraction on the bottom. You've got multiple fractions going on. Just remember to write it as a division problem. So after you write it as a division problem, we know that we do our keep, change, flip, or a cross multiplication. And we're going to do times a -9/8. We're going to put our 8 on the bottom, not on the top. So -9/8. And then 2 times a -9 is a -18. 3 times 8 is 24. And we can reduce that. So we can divide both of those by 6. So again, reducing fractions and putting them in lowest terms is part of solving any operation, or solving any fraction, no matter what operation you're performing. Always reduce at the end, put it in lowest terms. So a -18 divided by 6 will be a -3, and 24 divided by 6 would be a 4. So our answer would be a -3/4. So again, we have this scary looking fraction right here. Really, it's just a division problem, and every division problem is really just a multiplication problem. And then we just multiply across the top, multiply across the bottom, and then we reduce at the end. Another one that we might see is where we have a number on the top and then we've got some operations going on the bottom. So whenever you see a fraction and you have order of operations like this one down here that we're going to do in a little bit, treat the top as its own problem and then treat the bottom as its own problem. So treat them as two separate problems, work through them, and then reduce at the end. So that's something that you want to keep in mind when you start getting into these complex fractions where there's multiple operations on the top or the bottom. So obviously on the top, it's just a regular numerator, a regular whole number, nothing much going on there. So that can stay as a 48. But then we have 24 minus 15. So 24 minus 15 is 9. So 9 plus 15 equals 24. Now, when we look at that, 48 minus 9, or divided by 9, we might think that's it already in lowest terms. But remember, always check to see if you can reduce. And in this instance, we can. So both numbers can be divided by 3. So if we divide 48 by 3 and 9 by 3, 48 divided by 3 is going to be 16. 9 divided by 3 is going to be 3. So our answer would be 16/3. And again, resist the urge to want to put that into as a mixed number. So some of us might still have to break that habit, but again, it's okay. If you do write it as a mixed number, that's fine. Just remember that in algebra, you're going to get used to seeing these improper fractions, so it'll probably be more beneficial for you to get used to just leaving your answers as improper fractions. So again, treat the top as its own problem, treat the bottom as its own problem, simplify the top separately, simplify the bottom separately, and then reduce if possible. So now let's employ those methods for our last problem. And now we have multiple operations happening on the top, multiple operations happening on the bottom, and we'll do the same thing. So 2 plus 4 times 3. So we're going to treat this as its own problem and forget about the bottom. Just simplifying the top right now. In our order of operations, multiplication goes first. So we're going to do 4 times 3, which equals 12. and then we'll add that to 2, which would equal 14. So 2 plus 12 equals 14. So we just simplified the top, keeping it separate as its own problem. And now we can look at the bottom. The bottom is -3 minus 2 squared. So 2 squared equals 4. So we can rewrite this as -3 minus 4. And -3 minus 4 is going to equal a -7. Can we reduce this? We can. 14 divided by a -7 would equal a -2. So this would be the answer we would want to submit on our quizzes or exams, or we would get used to seeing in the back of the book. So if a number can be written as a whole number, if an answer can be rewritten or simplified to a whole number, we definitely want to write it in that format. So these are just a few examples of the problems you'll see in section 4.3 with the complex fractions. And again, making sure that we don't get freaked out when we see fractions and fractions. This is really just a division problem. And then for our complex fractions where there's multiple operations going on, treat the top as its own problem, treat the bottom as its own problem, and then reduce at the end.